And so we've got expressions for the x, the y, and the z coordinate in terms of t over here. We can substitute them into the equation for L2 and solve for t and hopefully get the right value. All right, you ready to go? Okay, so where I've got an x, I'm going to substitute 3 plus 2t. Where I have a y, I'm going to substitute a 1 plus t. Where I have a z, I'm going to substitute a negative 1 minus 3t. Minus 17, that's a really big number. Okay, I'm going to leave this part off by itself for now. Okay, and let's just do these two. Beg your pardon? Multiply each by 4, and then...
Or multiply 3 plus 2t by 4, and then the 1 plus 2 by 2.
Yes, or I could just multiply. Yeah, I can multiply both sides by 4, and it's going to eliminate. It will eliminate everything, right? Okay. 2t minus 4. Multiply both sides by 4. 4 cancels.
You simplify the both sides, you can simplify the other. Alright,
T minus 11.
Yeah, but on the other side, you had simplify.
Sorry.
On the second line, you already substituted.
Oh, I simplified here, this one,
Yeah.
but I hadn't simplified
Yeah.
that one. Yeah, that's right. Well, I don't want to get too simple too fast. There we go. I get a value of t equals negative 1. All right. Does that sound decent? So let's take the value of t. We'll substitute it back into our parametric equation, and 3 minus 2 is 1, minus 1 is 0, and negative 1 minus 4 is negative 5. So if I've done everything right, I'm not guaranteeing that I have.
Should be 2 instead of -5.
Oh, RJ is correct. Yes, this should be a 2, not -5. Okay. To make sure, what we need to do is we should substitute, we should just see if that point lies on the second line as well. So we should substitute the 1 and the 0 and the 2 into the symmetric equations. And we should get like each one of them equal to each other. What was the symmetric equations again, RJ?
X minus 7 over 2.
That was it.
Y minus 12 over 4. Z minus 17 over 5.
Okay, so I would substitute my x in. 1 minus 7 over 2 should be equal to -12 over 4, which should be equal to 2 minus 17 over 5. And it looks like every one of those values is equal to -3. Hooray! So it actually works out.
What was that the first one?
Yeah.
Maybe.
So since these are all equal, then that point does lie on both lines, and we've successfully found the intersection. So that's just a second technique that you've got, depending on what form the line is in, that you can tell. Okay. Fact is, in 3 space, hardly ever are lines ever going to intersect. However, we might get planes that intersect. RJ, in 2 space, what are the possible ways that lines could relate to each other? Yeah, so they could be parallel. And if they're parallel, what's going to happen when we try and get the intersection? Yeah.
You'll never find it.
We'll never find it. That's right. How could you tell the lines are parallel if you saw the equations?
You think it's slope one, they would have the same slope.
They would have the same slope. That's right. And how would you tell if it was in scalar form? So, would you be able to give me a?
They have the same direction.
Yeah, that's right. So give me an equation that is parallel to that one, but is not the same line. I can come up with one real fast. Do you want to see it?
Sure.
Okay.
I'll say 5, 7x plus 4.
Oh, okay. So you're thinking 5x plus 7y plus 4.
Yeah, I just converted it slope now.
Yeah. Oh, I see. Yeah. Yep. Okay. So yeah, we're just looking for lines. We're just looking to see if they're parallel. If they have the same slopes, they might be coincident. And if they don't have the same slopes, they have to intersect in 2 space. What are the possibilities in 3 space, though? So they could be parallel again, right? Yeah, they could be perpendicular like a bunch of ways, right?
Yeah,
Okay.
yeah, 60 ways.
So if they're parallel, they're never going to intersect. Is there another situation where they're never going to intersect?
Planes.
So actually, if the lines are skewed, so these two lines aren't parallel, and they don't intersect. I mean the lines being made by my arms right now, Meg. So they don't intersect. So these are called skew lines. And of course, in 3 dimensions, the most lines that you're going to have are, most of them are going to be skewed with each other. And the last rare case is where lines actually intersect with each other. Okay. Meg, do you have any questions? Speak through RJ.
Maybe.
Pardon me?
She shook her head no.
She shook her head no. Okay.
How would you would see it?
All right. So this is actually pretty straightforward stuff. I'm going to assign just a few questions out of the exercises, and then come tomorrow, I'm going to have speakers that I'll be able to hear people with. Okay, good. Is that all right, Meg? Look at that. You're throwing your arms up in the air. Thumbs up. Okay, good. We'll see you tomorrow.
Yeah.